Welcome to the next lecture in Geotechnics 254, and in this particular lecture we will be looking at phase relationships. The lecture is going to be fairly short, but I will be uploading some examples of calculations, and then also please have a look at the two videos that I provided the links for. Especially the video by Dr. Franke is quite useful, and he has a very nice way of explaining the concepts. De Zaghi, one of the very well-known soil scientists, he said something that is very important. The one thing an engineer should be afraid of is the development of conditions on the job which he has not anticipated. In other words, if your soil or preliminary investigation on site was flawed, you didn't pick up the amount of clay or the abundance of rocks in the soil profile, or you think you're working on shallow bedrock. If you look at the picture with the grass in the top, you might think those are solid bedrock outcrop, but the soil profile clearly shows that you have a very deep developed soil profile. So if this was not anticipated up front, you could have serious problems when you go to the field. So as I said, we are going to look at phase relationships for today. And phase relationships refers to the relationships between the solid material, the void space, the water or any other liquid, and the air or gas in the soil. If you look at this little picture, this is typically what soil look like in reality. This phase diagram describes the air, the water, and the solids. So on the left-hand side, the V is the total volume, VV is the volume of the voids, and the volume of the solids. And then volume of the voids is divided into the volume of the air and the volume of the water. Similarly, on the right hand side, the M stands for total mass. The top one, mass of the air, is 0, then the mass of the water and the mass of the solids. Quite self-explanatory actually. And we will be looking at a whole number of definitions. And remember what I said previously, it's a good time to start making a list of all these definitions and formula. I will give you the formulas or equations in a sheet for the purpose of exams, etc. But it's good to keep this list going and refer back to it every now and then. So SR is the degree of saturation and is defined as the volume of water over the volume of the voids. The void ratio, this is an important concept, E, because we will be using it a lot in determining consolidation, etc. So the void ratio is defined as the volume of the voids over the volume of solids. Porosity, on the other hand, is defined N as the volume of the voids over the total volume. Air content, A, equals the volume of the air over total volume. Bulk density, or rho, equals the total mass over the total volume. The water content, W, is the mass of the water over the mass of the solids. And then specific gravity is defined as GS, and it equals the mass of the solids over the volume of the solids times the density of water. So if we play around with these formulas, we will come to other definitions. So the degree of saturation, which is the volume of the water over the volume of the voids, can also be described as the water content times the specific gravity divided by E, the void ratio. The air content, on the other hand, A, equals the volume of the air over total volume. So it's the void ratio minus the water content times specific gravity divided by 1 plus the void ratio. And that can also be described as porosity times 1 minus the degree of saturation. Bulk density rho was defined as total mass over total volume, and it can be described further as specific gravity times 1 plus water content divided by 1 plus the void ratio times the water density. And further developed, it becomes the specific gravity plus the degree of saturation times the void ratio divided by 1 plus the void ratio times the density of water. This is the end of this particular lecture. As I said, very short, but some very important definitions and equations already given. And in the examples, you will see how this is used. And this sort of calculations is actually quite important, and we'll be using it a lot in the future. Thank you.